Looks like our numbers are filling out, so why don't we go ahead and get started. Thank you everyone for joining us. Wanted to introduce myself really quickly. My name is Drake Quigley. I'm an account manager here in our Chicago office. With me today, I have the pleasure of having Richard Cromwell and Hunter Bernstein. They will be the technical gurus going through some of our FDM printers. You can see the machines behind them too, which will be a nice interactive way to showcase these machines. Like I said before, if you guys have any questions, please feel free to use the question section in the webinar to send us any questions you might have. We'll try to take a few breaks and get to them. And then at the end, we'll definitely get through any unanswered questions that we have. So without further ado, Richard, I will hand things over to you to get things going.
All right, thanks, Drake. Hello, everybody. My name is Richard Cromwell. I am an additive manufacturing applications engineer for GoEngineer, and I also run the AM lab here in Auburn Hills, Michigan. And today we're going to be talking about industrial FDM 3D printing for engineering and manufacturing. I'm joined by my colleague, Hunter Bernstein, who I'm very happy is able to join us from Salt Lake City, where he's going to be showing us some of the machines that I don't have here in my lab, but he does. And so why don't we get started? So I want to kind of frame this as to how these machines can really bring your manufacturing and engineering applications to a new level, and to help with some of the challenges that we're facing in today's manufacturing environment. So challenge one that we're encountering, and this is something that I hear over and over again when we're doing discovery calls and talking to customers and clients, is that it is a challenge right now to find and retain highly skilled labor. And part of that is because of, decades of outsourcing a lot of those jobs overseas. And now with supply chain issues and things like that, we're trying to bring all of that back into the United States. But that knowledge base has been eroded to a point where it's becoming extremely difficult for people to find skilled machinists and fabricators. And so one of the tools that employers can use to find employees is finding the technologies that they have been trained in and use those to attract a new labor pool. Challenge two kind of goes with the first one, is less labor means that they're going to need more automation and a need for reliable lights out processes. Challenge three is higher customer expectations. Customers demand well thought out products, designs, and they require frequent design iterations so that they can optimize their products. Challenge four has to do with software, data, and IP protection. Connected manufacturing efficiencies and keeping data safe is a big concern, and we have some solutions for that now that were not available before. And challenge five, the only constant is change. A lot of manufacturers who adopt additive manufacturing think that they're ahead of the curve. They're really behind it. It needs to be more of a focus in their tool set. So where does GoEngineer come in? GoEngineer, this is our mission statement. We provide design and manufacturing tools with expertise that enable customers to reduce the cost, risk, and time required to go live with new technologies and ultimately new product introductions. And so one of the ways that we do that is through our additive manufacturing portfolio. And so we're very fortunate that GoEngineer is a diamond level partner, reseller for Stratasys. We're the largest Stratasys reseller in North America. And we have a broad spectrum of technologies in our AM portfolio. Well, everybody is relatively familiar with FDM, or Fused Deposition Modeling. That's what we're going to be talking about today. And if you look at this chart, the complexity to deploy is once you acquire a machine, how difficult is it to integrate it into your organization, and the site requirements and the training involved. FDM, you'll see, is on the low end of that spectrum. It is relatively easy to deploy. And there's two different levels of cost. And today we're going to be talking about the F123 series and the F770 specifically. But we also have PolyJet, which is great for multi-material and full color prototyping. And we also have SLA as a new addition to our portfolio. We have the Neo line of SLA machines. These are really top-class stereolithography 3D printers. And those round up the prototyping options that we have as far as 3D printing. But there's a new category of production printers that has been come out this past year. P3 is essentially like a DLP. It's like a resin-based system, and it's a really fantastic technology that allows you to do really precise approximations of injection molded parts. And there's a lot of really neat different resins that you can use with different mechanical properties. Some of them are elastomeric, some of them are high heat deflection. And so that's a really cool technology that is up and coming. Actually, Hunter knows quite a bit about that. And then there's SAF, which is selective absorption fusion. This is another production-based, higher volume of parts technology. It's good to think of it kind of like a powder bed fusion system, but it's like a 2.0. It's the next generation of that technology. And you'll be hearing a lot more about that in the future. And then finally, we also have metal 3D printers. We have the Exact Metal system, which is our lower cost metal printer. And then we have the top of the class Velo 3D systems, which basically can print metal with a very little support material. So let's move on. So talking about Stratasys FDM portfolio, there's a range of machines across a range of prices. We have the engineering series, which I'll be talking about a little bit. I have one behind me here. It's the F170. And then Hunter's going to be talking about the 370, which is their big brother, and the brand new Stratasys F770. I'm really excited for you guys to get a peek at that and see what that's all about. So just an overview of some of the things that the F123 series is capable of. It's easy to use, and it can use GrabCADPrint, which is Stratasys's proprietary slicing software. They're incredibly office friendly. They're not loud. They don't produce a lot of odors. They have great accuracy, detail, and repeatability when it comes to printing complex geometries. And we have some data to back that up I'll share with you. They have a fast draft mode that you can print in PLA. They have a big build envelope and 2 times the throughput of some of the competitors' machines that are the same size. And then we also have access to engineering grade materials, a cost-effective PLA option, and then soluble support. And we'll talk about that more later too. There are 4 slice heights with a single head. One of the reasons people ask why we bundle all of these specific printers together, the F170, 270, 370, and the 770, is because they all share the T14 head. Okay, and what this allows you to do, it's a plug and play cartridge-based head and tip, and it allows you, with that single head and without changing tips, to be able to extrude 4 different slice heights on the F170, 270, and the 370. Where, like, if I have one of my bigger, like, Fortis machines, changing slice heights is quite a bit more involved. I have to open up the top, climb up a ladder, remove the head, and change the tips. All of that is not part of this system at all. Intuitive interface. It has a 7-inch touchscreen where you can have all of your materials, your cues, the wizards that you need to run for maintenance. And it also has a camera up in the corner here so that you can monitor your prints remotely as if you have GrabCAD server set up. And you can also initiate prints remotely as well. And then another neat thing is that it uses standard build trays across all materials. And I'll show you those in a minute. So let's look inside. We have extreme performance and reliability testing. Stratasys has been manufacturing 3D printers for 30 years. They invented fused deposition modeling. And they have continued in every generation of their machine to push the performance, and reliability testing is a huge component of that. Extensive extrusion control. This is, there's wizards in here that allow you to change the, you can go in there and purge and do all the things that you need to do manually to test the extrusion, but all the fine extrusion control that is tailored specifically to each model material, those are all handled internally, so you don't really have to worry about that. It's all done by software. High performance, durable components. These are tough machines made for tough environments. Anti-curl design features. This is pretty neat too, and this actually goes a little bit deeper into the software. GrabCAD has added some functionality that allows you to create geometry that helps to maintain the integrity of your prints so they don't curl. Specialized extrusion algorithms. These are specific to each material. Each extrusion algorithm has been finely tuned during a tremendous amount of testing so that you get the best results right out of the box. Rugged frame and enclosure. Automatic tip detection and calibration. This is an important one. There is not like, like when you have FDM printers that are geared more towards consumers, there's a lot of the things that you have to do, like check your tip height above the print bed, and you're like sliding pieces of paper under there to make sure that it's set up before, so you can get good first layer adhesion. All that stuff is gone now. You don't have to worry about that. This will calibrate itself so you get the get everything set up right from the get-go. Highly tested and optimized material. I think we have some data to back that up later on in the presentation about how many hours these machines are tested before they're actually put on market. Tight temperature uniformity. This cabinet basically functions as an oven, and it allows you to have a uniform thermal experience, that the layers that have already been printed and the new layer that's being extruded on top, you're going to get better adhesion because you're printing in this hot environment. And it's a closed-loop, fine-tuned servo control. So that has to do with the accuracy and precision of these machines. Now, the F123 series comes in 3 flavors. We have the F170, the 270, and the 370. The 170 and the 270 share the same cabinet. They basically look exactly like this. The differences are the 170 has a 10 by 10 by 10 build chamber, where each successive model, you gain 2 inches in X and Z. So the 270 is 12 by 10 by 12. It's 44% bigger than the 170. And then the 14 by 10 by 14 in the 370 that you'll see shortly. The materials that are available on the 170 and the 270 are the same: ABS, CF10, PLA, ASA, TPU, and the QSR soluble support. There's some additional materials that are available for the 370, like Duran, and I'll show you some examples of that later, PCABS and ABS ESD7, which is like an electrostatic version of ABS. The other thing that the 370 has access to, provides you access to, that you don't really get with the 170, the 270, is in addition to having all of the capabilities of GrabCADPrint and the advanced FDM functions inside of that software, you gain access to Insight, which is a package of FDM. It's a software application that is used in the Fortis line that gives you tremendous amounts of control over the contours and rasters, and much more so than you can get in GrabCAD. So this has to do with the part dimensionality, the part dimensional accuracy and the reliability of these machines. Stratasys did a test of 45 dimensional accuracy parts printed on 3 different Stratasys F370 printers. They took over 1,100 geometric measurements, and the result was 99% had accuracy within 10 thou. And the official printer specification for the F123 series, you know, plus or minus 0.2 millimeters. And overall, when I measure the parts that I'm getting off of these machines, I'm really impressed. And a testament to that, and this is also something that to think about. Even though like the 170 isn't like a huge printer, it doesn't have like a giant build platform, it's really easy to print things in 2 parts and just partition them. And just to show you how accurate these are, I didn't sand these or anything, and they fit together really well. And it's basically seamless. So that's a strategy you can, of course, employ if you don't have the build volume to print the bigger parts. But Hunter's going to show you that we have a solution for that, just in case you don't want to glue parts together. Okay, so I'm actually going to stop sharing my screen for 1 second if I can, and I'll show you the machine a little bit more. And we'll focus on the camera. Okay, so this is the 170. It just plugs into a normal 110 power outlet. You don't need anything fancy. And here's the where you do most of your work as the operator. You're going to be initiating prints and running your wizards and checking your material. But see, we have this is the build trays that we're talking about. All you have to do to release these is push it down and it pops right off. These are reusable, so you can just break the part off and then, you know, take a chisel, clean off this little bit extra, pop it back on the machine, and you're back up and printing again. Once you take off the part, typically I'll remove some of the support material just so I don't saturate my ultrasonic cleaner, because that's where this goes afterward. You dunk it in the ultrasonic cleaner, it will dissolve that support material, leaving me with just the perfect part. I'll show you up here. Up top here is where the extruders are. There's one for model material and one for support. They're both the same head. You can just dedicate, once you dedicate one to support or model, that's what it's going to be for the rest of its life. They typically last around 1,500 hours. If you're going to, some of the materials, the PLA and the ABS CF10, they have their own specialized heads. The ABS CF10 is green. The PLA is gray. PLA, you don't need to use soluble support. So you will actually have a little fan that goes up in there to help cool the PLA. Super fast printing with that material. And then the material bays on this machine, there's only one model material and one support material bay. The 270 and the 370 that you can see Hunter with, those have 2 bays, allowing you to have a lot longer prints going. It will automatically switch material between the 2 rolls once one runs out. And it also allows you to easily hot swap materials while the machine is printing. And so, since we have Hunter over there by the 370, I'm going to, at this point, toss it over to him, and he can talk about the merits of that system and show it to you a little bit. So what do you think, Hunter? Can you hear me?
I can hear you. Can you hear me?
Okay, I can.
Okay,
This
great.
is great. This is our first simulcast, friends.
Yes.
So
So
bear with
on
us
the
here.
370, we have the 4 bays, and they're totally enclosed from the environment. So you're not going to be getting any moisture in there. It's a very good seal. They also have an RFID chip on each of the rolls. So the machine knows exactly how much material is left. Therefore, you don't need to worry about it totally running out of material and ruining a print. If that does happen, the machine will go into a pause state if there isn't a secondary roll to automatically switch over to. It can sit in that pause state for indefinitely long unless you run into a power outage or something along those lines. Really quick, I want to show my screen. So right now I'm connected to the 370, and right here is the onboard camera. So you can actually see there's no part in there, but you can actually see the parts when they're printing. There's my shadow updating on it. And it gives you any errors that you may have on the machine. Currently, it's telling us that we've exceeded the recommended hours that each print head should be using. So it's monitoring all of the systems on board, checking to make sure that nothing exceeds its expected lifetime, and if it does, it will prompt the user. Same goes for routine cleaning and maintenance of the machine. If it goes too long without certain tasks being performed, it will remind the user that it's a good idea to keep up with the simple maintenance tasks. Nothing is too technical. If you can read a IKEA instruction set, you will have no problem performing the basic maintenance required here. So with that, do you want to hop back onto the slides, Richard?
Okay.
All right. Bear with me one moment.
So while we're doing that, it might be a good time. We've had a couple of questions come through.
Okay.
One regarding materials. Somebody asked if they can use any materials they want from, like, let's say, other FDM machines.
Nope. One of the things about Stratasys is that you are going to stay within their material ecosystem on the FDM machines, and that's for a good reason. These machines are made to, not be fiddled with, and not a lot of rigmarole to get them printing. And part of the reason that you run into problems with a lot of other systems is because of the quality of the materials that you're putting in. I just read something online in a forum that somebody was saying that it's always worth it to them to buy the best materials, because it ultimately ends with less machine maintenance and less failed prints. And that's certainly the case. So to facilitate that and make that easier for Stratasys' customers, they test and they take these materials that they create and then test them extensively, so that you can trust that when you're loading these materials in the machines, and you're going to get a good quality print from them. So yeah, you want to, it's not an open system in that regard.
And then we have one more question that was about the support removal. The question was, how long does support removal take?
Well, that's a good question. It depends on how much dissolved support material you have in your ultrasonic cleaner. So when I get a new bath going, my ultrasonic cleaner is 22 gallons, and it's water, but then you add in this caustic bath powder, and that raises the pH, okay? And so as that bath becomes saturated with dissolved support material, the pH begins to drop, and the efficiency of the ultrasonic cleaner removing support material begins to degrade. but typically it's anywhere between 45 minutes to a few hours. If you have a part that has a lot of internal cavities and a tremendous amount of support material on the inside, those will take longer to dissolve than something simple. But also, it depends on which soluble support material you're using. QSR and SR35 have a tendency to dissolve a little bit quicker than SR30. So, but yeah, generally it's not too long. It's 45 minutes to a couple hours.
Excellent. I will let you guys get back to it, and if there are any other questions, definitely keep going and submitting them to us, and we'll answer them as we can.
Yeah, please do.
Okay, so we went over the 370. This is the 770, the latest addition to the FDM lineup. Why was this machine introduced? Where does it fall? What is the need for it? A lot of big OEMs and manufacturers, they already are printing large parts for many jigs and fixtures within the same tray. All of this requires a very big printing envelope at also a low and economic price point. Hence the need for the 770 introduction. We can look here at some of the OEMs that have already been implementing FDM, and there's even more that are unlisted here with documented white papers and supporting case studies, all available on Stratasys' website, and a handful are available, I think, through some of our blog posts as well. You want to click through, Richard? So some quick facts about the 770. It's 39.4 inches in the X direction by 24 by 24. This is over 13 cubic feet. And it prints with two main materials, ABS and ASA. These two materials are the most commonly used for rapid prototyping, jigs, fixtures, and other assembling components that need to be made quickly and cost effectively. This machine uses GrabCADPrint and Insight with 3 slice heights available. It has also been optimized for large part printing, meaning it's not going to use the same settings on the 370, 170, and 270. If available, this will run a little bit quicker than all of those machines, making it ideal for really big jigs, fixtures, large panels, and assemblies. We can look here at a car fender. Oh, you're not seeing me pointing at it. That was printed on the 770. The printed part is on the far right of the screen. It was then primed, well, sanded, primed, painted as a part of the prototyping process. So the 770 is able to produce extremely large parts all in one single print. Richard had showed earlier the part that was split into 2 pieces. On a machine like this, you no longer need to be doing that. Let me give an example. This is a turbine blade that we had printed, and I believe it's about 46 inches long. We oriented it in a corner to corner 3-dimension orientation. This is another part. I'm not sure if you can see the layer consistency. But very, very amazing surface finish. As I had mentioned earlier, this uses a slightly different parameter set for determining the toolpath. This allows for faster prints to be made at 1.4 approximately cubic inches per hour using ASA and ABS with a soluble support. You can also connect this machine with MT Connect. So if you're already on the Industry 4.0 train and you want to integrate this machine to your current ecosystem and do mobile monitoring, data logging, etc., it's set up, ready to go out of the box. This machine uses the same F123 head. However, you cannot swap it. It will only do one head for the ABS and ASA. Richard had mentioned you have a green head, different colored heads. That's unapplicable here. And you also have 3 slice heights, 7th thou, 10th thou, 13th thou. The build sheets are a polycarbonate, flexible, that's held down by vacuum. So you can remove the whole tray. So let's have a look at some of the internals here and how they were able to set the price point at what it was. A lot of that I've kind of already hinted on earlier with only being able to do 2 materials. So you don't have all the engineering grade materials that the Fortis lineup has or the F370. So there are 4 linear rails, 2 on the front end, 2 on the back end. This is to help with rigidity of the frame. It also uses a linear motor and magnetic encoder to drive the x-axis instead of a servo belt setup like you would commonly find on the other machines. This is a very precision-based system. You can find them in a lot of CMM devices, and they also provide extremely high torque. So high torque applications they are also commonly used in. There's a thermal expansion bridge right here connecting the x-axis to the actual y-axis. What that does is if the temperature is too high, it will cause the materials to expand, the actual frame for the machine. This thermal expansion joint compensates for that and maintains the same dimensional accuracy regardless of any temperature differentiation happening between the printer, inside the chamber, above the chamber, and the outside environment. Has the longest heated bed available on any Stratasys machine. The Fortis 900 and the Fortis and the F770, they're extremely close in the size. However, this is at a much lower price point, and yeah, really good machine. Down below, let's see if I can zoom in on those. These are our material cartons. These are a lot bigger than what the F170, the 270, and the 370 are using. There's 200 cubic inches of printing material in here. That enables prints up to 140 hours long. Stratasys did a lot of testing with this machine and a lot of fine tuning with it to get the best and optimal results that they can. That includes over 33,000 hours of actual reliability testing, 4,600 parts, 14,000 hours of motion testing and 60,000 cubic inches printed. All of the parts had a tolerance within 0.1 inches, and the machine has an absolute positioning repeatability of 4 thou. All right. Well, I'm going to start closing it up. And Richard, if you want to take over from here.
Sure.
Cool.
All right. Thank you so much. It's a
Richard, we do have a couple of
looking
questions
machine.
if you want
It's
to.
colossal.
Yeah, it's huge. Did you want to answer a couple of questions that we had come in about the 770 here before we move on?
Yeah.
So one of the questions that we got was whether or not there was a different input format for the 170, 370, and then the 770. I think that's referring to the file format, correct?
Could be, but no, all of these machines are run by GrabCADPrint, which can take native CAD files and then turn them into printable models.
Awesome. And then there was another question, 770, obviously with it being much larger, are there any special facility requirements for it?
I'll let Hunter answer that since he has one right there.
Say again? Sorry.
What are there any special facility requirements for the F770? I can think of a couple.
Question. So, sorry, I'm going to go into the storage room. It's really loud in our lab. Yeah, you need to have bay doors. The machine is really big. So we have bay doors that we brought the machine in through. You need to have a forklift that's capable of lifting 2,000 pounds with forks that are 5 feet long, 5 inches wide. You probably don't want to put this on a second floor. The ground needs to be able to support 2,000 pounds as well. That's how much the machine weighs when it's fully crated and shipped. It's quite a big machine when it comes in. I think it was like 8 feet tall or so. Regarding ventilation and air quality control, there is no external ventilation that's required. There's no air, as far as I know, I guess dust levels in the air. I'm sure once you hit an unacceptable level, you wouldn't be able to do any type of manufacturing in that environment anyway. So as long as you're not putting this, say, with a bunch of loose resins that are going to be splashing all across the room and everything, you should be totally fine. The biggest concern, it really just comes down to the overall size and the weight of the machine. It does run on a 220 power supply with, I think, a 5 lead. So you would want to check with your local electrical laws and also make sure that all of that is, or get a local electrician to come and install that for you. Beyond that, I don't think there's any additional requirements.
Hunter, does that require 3-phase?
It is a 3-phase, yes.
Yeah.
Yeah. So, and when you get it, it doesn't have a cord on it. You can put a cord on it, or you can hardwire it in, but this is why you need to have an electrician come in. So it's no plug and play type deal, unfortunately.
All right,
Not
great.
bad for
Thanks.
that size, though.
No.
One last question before we let you continue, Richard. What is the maximum temperature that these FDM machines that we're talking about can handle?
The printed parts or the machine itself?
I'm not sure, but I think in general, the environment, if we want to talk about the environment, it would be pretty
so I'm pretty
standard.
sure on all F123 and the 770, the maximum chamber temperature is 80 degrees Celsius. That is what it will get up to for the printing environment. The bed itself, I believe it's 100 C. It might be 110 on the F123 series. And then Richard, can you answer what the highest extrusion head temperature is? Is it 285?
Honestly, I can't. I'll tell you, one of the advantages of being a Stratasys, working with these machines, is that I typically don't have to think about extrusion temps or anything like that, like you would with a consumer printer. That has to do, going kind of with this slide that we're looking at here. Stratasys spends a lot of time tuning the printer and the materials and the software to work together. And so the build chamber temperature and the tip temperature will change based on the material that is loaded, because that's the and that's how Stratasys validated that material to work best. And so it's everything working together. We kind of have a tendency to fixate on the machines a lot because they're cool, and in the case of the F770, they're huge, but it's only one part of the total equation, where the quality of the materials that go into it, and then as well as the software, which is pretty outstanding as well.
Yeah, also going along on the same line, before we get too deep into a rabbit hole, within GrabCADPrint, it automatically sets what the temperature should be for the machine. You don't even have the option to change what temperature it is. Like if you're using Simplify 3D or Cura or any other open source slicing software, those allow you to tune, say, like your retraction parameters, your extrusion temperatures, etc. The Stratasys machines, they are built and equipped and tuned to work right out of the box and leave you with your day-to-day tasks, not figuring out how to get this machine to run properly and be getting this or printing this material. That also kind of goes with why they have a closed material ecosystem, is they can validate all of their material. You can go to any third party and get material, but I can say from personal experience, you can buy the same material from the same vendor and you're going to get two different results because you purchased them from two different batches. With Stratasys, if you order a material 5 years ago, as long as they are still selling that material today, it will be the exact same material. They aren't going to be tweaking it. They're also going to ensure that the manufacturing consistency and repeatability retains throughout the entire lifetime of that product. So yeah, I'll wrap it up there. Otherwise, we'll get too deep.
Yeah. You can tell we really like talking about 3D printing, and we can do it ad nauseum.
There we go.
So this is just a slide that goes over some of the things that Hunter was talking about, including the price of the system, which is considerably less than an F900 if you're looking for a large format 3D printer. This is something new. There was a press release actually this morning about this. Protect AM is a new program that Stratasys is rolling out. It's a data security platform for the FDM printers. It has a lot to do with the U.S. Department of Defense compliance. It's done by through a Red Hat Enterprise Linux software, which is what the DoD prefers. And it significantly reduces vulnerability to cybersecurity threats. Presently, as of October 1st, the Protect AM is available on the Fortis line of the 450MC, and it will be available for the F370 and F770. It's projected to be available in Q1 of next year. So you'll be finding those machines inside of DoD contractors. So the last part of the equation of getting good quality prints easily and quickly is the software. We saw it briefly when Hunter showed it. I'm not going to show it again because we're running out of time. But like we said before, it reads native CAD files. You can basically just click and drag files from an open window right onto the build platform, and it will put them together. You can take It's a really powerful software. You can take SolidWorks assemblies and then disassemble them and apply different printing strategies, different infills, different contours and raster thicknesses, all inside of the software, and then reassemble it. So there's a lot of really terrific applications. It connects to the Stratasys FDM printers as well as the PolyJet machine. So if you have a service bureau or a lab that has multiple technologies, you can use GrabCAD to control all the printers and do your scheduling and things like that. And then you can increase productivity with print management and remote print monitoring. That involves using GrabCAD server. But these machines are made to be used perpetually and to run constantly. And you can build up a big queue of prints. And there's also a GrabCAD Shop, which is essentially a project management software, but it's geared more towards the manufacturing environment and specifically to 3D printing. It lends itself very well, and you can basically have people upload files to a cloud-based project management software, and then it will download those files directly into GrabCADPrint. So it gives you a lot of, it's a really easy and powerful workflow. So just in kind of closing, we're running out of time, but I just want to leave you with a couple of things, and maybe we'll do a quick material review. You want to imagine what you can make with these machines. You can make end-use parts. There's a variety of tooling applications, production parts to help you get increased throughput, and robot end effectors. That's a big one. That's a hot area right now. I printed this guy. There's little suction cups that go down here, and one of the great things about robot end effectors is that you can have pneumatic channels built in, and you can create something that normally would take a ton of parts. You can combine that assembly into one part. Inspection and CMM aids. This is a big one. So we have this part here, and you can see it's set up for a CMM inspection. And let's say that we didn't have that part yet. You can also use FDM to create surrogate parts. Functional prototypes, because of the various engineering thermoplastics that we have, including ABS CF10 and Duran, which are really robust, strong materials with great mechanical properties. You can make some pretty spectacular prototypes. Ergonomic aids for the factory floor, and even more. If you look around your shop, and I'm sure that you can see different areas, whether it's engineering, assembly fixtures and jigs, we create a lot of those. Painting masks, there's just a endless amount of opportunity to improve efficiency through bringing 3D printing into your organization. We'll just do a quick 5-minute material review. ASA is the standard all-purpose prototyping material. We prefer it over ABS because it does have UV stabilization properties that have been increased through a chemical additive. ABS is still, because some people have been printing with it for so long for certain applications, they want to keep using it, don't want to switch to ASA. So ABS is still available, and it comes in a variety of colors. PLA, a lot of people look at PLA as being more of a hobbyist level material, but it does have some very interesting mechanical properties, especially when compared to ASA and ABS, and you start getting into cryogenic temperatures. PLA actually does pretty well in comparison to the others. There's some also neat translucent versions of PLA that are available, which can be great for a variety of applications. ABS ESD7, this is for the 370. It's not on the 120 or the 170 or the 270. This is really an electrostatic dissipative ABS. They have carbon fiber nanotubes that have been mixed in with it. And this is great for tools, jigs, and fixtures in a clean room environment, or if you have like anything with automation conveyor belts where static buildup can cause problems. This is an excellent material to use. PC-ABS, if ABS isn't strong enough, you can have a PC-ABS blend, which gives you the highest impact strength of Stratasys FDM materials. This is one of my favorites, FDM TPU 92. You can create flexible parts. This is great for seals and gaskets, hoses. Look at that huge thing. That's a nice one. Duran, this is my favorite material on the system, actually, right now. I really, really like it. And it has a super smooth surface finish. It's great for jigs and fixtures that are going to make contact with Class A surfaces that you don't want to be marred. And then the ABS CF10, which is ABS with chopped carbon fiber. And this is great for the factory floor. This is a rigid and tough material. It gives you a really high quality, nice surface finish. And I did a webinar just focusing on that last year. So we'll talk about the soluble support. There's two that are available with this system. The F170, 270, and the 370 all use QSR soluble support, which is identical to SR35 that you'd find on the Fortis line. It dissolves very quickly and cleanly. The SR30 is actually what I use mostly on the Fortis line, and that's what you're going to find with the F770. And so with that, I think we're going to be drawing it to a close. But before I go, I just want to say thank you for taking the time out of your day to join us. I hope that you learned something. I know that I did. And I just want to give you an overview really quickly of the other services that GoEngineer offers. We have over 30,000 SolidWorks users on subscription here at GoEngineer. We're the #1 reseller of SolidWorks for 5 years in a row. We offer outstanding training and instruction. We have over 150 certified technical agents to assist you. We have a 3D printing service bureau to assist in prototyping and low volume production, but also to validate additive manufacturing technologies and materials before you acquire a machine for your organization. We have over 40 offices now spread across the United States and moving north of the border. So thank you very much. I encourage you to sign up for our newsletter, look into our SolidWorks training, and please like and subscribe our video and subscribe to our YouTube channel where we have over 22 million views right now.
Excellent.
All right.
Thank you, Richard.
Thanks, Hunter.
Thank you,
You did great, man. That was awesome.
Thanks, everyone.
And we'll see you next time.
Yeah, have a great rest of your week.